This is Geometry Unit 6, Lesson 6 on the Isosceles triangle theorem. Now, the Isosceles triangle theorem says, if two sides of a triangle are congruent, the angles opposite those sides are also congruent. Now, a little shorter way of saying that is base angles of an isosceles triangle are congruent. Now, we kind of talked about that a little bit when we were talking about ordering the sides of a triangle based on the angle measure. So, if you have two sides congruent, that means two angles are going to be congruent. But let's actually formally prove that this is really true. So, we're going to prove this theorem using an angle bisector. The plan is to bisect the vertex angle of the given triangle and then prove the two new triangles are congruent. So now that we know how to prove triangles, let's see if we can come up with a way to prove that the base angles are congruent. So first of all, we need a triangle. So our given value is that we are going to have an isosceles triangle. Here's my isosceles triangle. Okay, I'm going to call my isosceles triangle ABC. And the two sides that are going to be congruent, I'm going to say AB is congruent to BC. So I'm given, that's what I know. I have isosceles triangle ABC, where AB is congruent to BC. Okay, now if I want to prove that the base angles are congruent, what two angles am I trying to prove are congruent? Well, if these two sides are congruent, the angles opposite them would be congruent, so we're trying to prove that angle A is congruent to angle C. So that's what we need to do. Here's how we do the proof. Okay, so the plan is to bisect the vertex angle of the given triangle and then prove the two new triangles congruent. So, first of all, if I am given that I have an isosceles triangle, ABC, where AB is congruent to BC, that's given. All right, now I need an angle bisector. Now, can I draw an angle bisector anywhere I want? Sure I can. So I'm going to draw an angle bisector that bisects the vertex angle of the triangle. So the vertex angle is where the two congruent sides meet. So I'm going to bisect angle B. So here's what I'm going to do. I'm going to draw, I'm going to call it BD, the angle bisector of angle ABC. So I'm going to draw that here, starting at B, and I'm going to draw it down like this on AC so it meets point D. Now, why can I draw an angle bisector? Well, every angle has only one bisector, or a unique bisector. So there's only one bisector of every angle. So every angle, has a unique bisector. There's only one way you can bisect that angle. All right, so if I know that BD is the bisector of angle ABC, what do I know is true? Well, I know that angle ABD is congruent to angle CBD. Because a bisector divides a segment into two congruent segments, or divides an angle, excuse me. Into two congruent angles. So I know those two angles are congruent. Now, if I want to prove these two triangles congruent, what am I missing? Well, I have a side and I have an angle. How about reflexive? So BD is congruent to BD. By reflexive. So what have we proved? Well, we've proved that the two triangles ABD and CBD are congruent by side angle side. All right, because this is a side, the reflexive is a side, there's an angle, and we were given another side. Side, angle, side, side, angle, side. So those two triangles are congruent. Now, if those two triangles are congruent, are angles A and C also congruent? Yeah, they are. That's by corresponding parts of congruent triangles are congruent. So angle A is congruent to angle C by CPCTC. So we have just proved the isosceles triangle theorem. the base angles of an isosceles triangle are congruent. So we never have to do that again unless we're asked to, of course. So basically what this tells you, if two sides are congruent, the two angles opposite them will be congruent in a triangle. Or in an isosceles triangle, base angles of an isosceles triangle are congruent. Now, it's also important to be able to interpret the given information in order to draw a diagram. So, we are given triangle RAT where RA is congruent to AT. So I can draw any random triangle I want. So here's my triangle. RA is congruent to AT. Alright, so that means RA and AT have a common point of A, so the point that has the common point here, I'm going to call A right here. That's going to make that the vertex angle. So RA is congruent to AT. Now, if RA is congruent to AT, doesn't that make this an isosceles triangle? Well, if that's an isosceles triangle, then the base angles are congruent. So, if RA is congruent to AT, what two angles are congruent? Angle R is congruent to angle T because base angles of an isosceles triangle are congruent. So if you can draw the diagram and you can show me that you have base angles, if these two sides are congruent, the base angles, R and T, are also congruent. Now, we have triangle CAT, shown at right, has a perimeter of 52, and we want to find the value of x. Well, what does perimeter mean? Perimeter means that we're going to add up all the sides and they will equal 52. So that means that CA plus AT plus CT will equal 52. So, adding those up, x squared plus 5x plus 2x plus 8 equals 52. Now, this is a quadratic equation, so I want to combine my terms and get it equal to 0. X squared plus 7x plus 8 is equal to 52. Subtract the 52, and that gives me x squared plus 7x minus 44 is equal to 0. Factor, factor, factor. Double bubbles. X and x. The factors of 44 that add up to 7 would be 11 times 4. And remember, watch your signs here. It'd have to be plus 11 and minus 4 to add up to positive 7. Set the factors equal to 0. And x is equal to negative 11, and x is equal to 4. Now remember, these are sides of a triangle. So can x equal negative 11 and plug it in here? No, that's going to give me a negative length. So I actually have to reject this side. Now, so we have to reject that one. So the value of x is x equals 4. Alright, so if we know that x is equal to 4, we found that, we want to find the values of y and z. Well, y and z are angles of the triangle. So in order to know about the angles of a triangle, we have to know about the sides. So the first thing I'm going to do is figure out what the length of the sides are based on what I just found x was. So that means AC right here is 4 squared, which is 16. This side is 5 times 4, which is 20. And this side is 2 times 4 is 8 plus 8 is 16. So based on the sides, what do we know about this triangle? It's isosceles. Alright, so triangle ACT, or CAT, is isosceles. And that means these two sides are congruent. So if AC and TC are congruent, what does that tell me about the angles? Well, let's see what we can figure out. If AC is congruent to TC, the base angles are congruent. Well, where are the base angles? These are the two sides are congruent, so the base angles would be those two. So since CA is congruent to CT, angle A is congruent to angle T. So that's one fact that I know would help me find y and z. So that means 2y plus 3z is equal to 5y plus 30. Alright, so I have y and z there. Now, I need another equation. Since I have two variables, I need two equations. I need to know something else about angles. And we also know that the sum of the angles of a triangle is how much? Angle C plus angle A plus angle T should equal 180 degrees. So angle C is Z. A is 2y plus 3z. And T is 5y plus 30 will equal 180. So knowing the facts about those angles helps us. All right, now I want to use substitution, but I'm going to clean this up a little bit to make this less arduous. So combine your terms here. This gives me 7y plus 4z. I'm going to move the 30 over here, is going to equal 150. Now I want to combine my y's here. That gives me 3z is equal to 3y plus 30. Now this would be pretty easy to solve for z. All I have to do is divide by 3. So z is going to equal y plus 10. So now I can substitute. I can take y plus 10 and plug it in for z. So I have 7y plus 4 times y plus 10 equals 150. Distribute, make sure you get both terms. 4y plus 40 equals 150. 7 plus 4 is 11y. Plus 40 equals 150. Subtract the 40. 11y equals 110. Divide by 11, and y is 10. So I now know y is 10. And I can also find z because z is equal to y plus 10. So 10 plus 10 is 20. So it is very important to know when you have an isosceles triangle which sides are congruent and which ones would be the base angles from the triangle. Now the converse of the isosceles triangle theorem is also true. We're going to prove that later on your homework, but the converse basically in reverse. So the converse would be if two angles of a triangle are congruent, the sides opposite them are congruent, which makes making the triangle isosceles. So basically what I'm saying is if you know you have two angles congruent, you can automatically say that two sides are congruent and that the sides opposite the angles. So knowing that, determine which two sides of triangle hug here are congruent. Well, all we know is these three angles. We don't know anything about the sides. So we need to know the angle measures first. All right, so we know what about the angles of a triangle. They add up to 180 degrees. Angle H plus angle U plus angle G equals 180. We always know that. Plugging in your value, H is 3x plus 12. U is 2x plus 42. And G is 5x plus 6. Oops, 5x, not 56. So combining your terms, 3x, 2x, and 5x is 10x. 12 plus 42 plus 6 is 60. Solve for x. 10x minus the 60 here is going to equal 120. So divide by 10, x is equal to 12. So plugging in your values, angle H will be 3 times 12 is 36, plus 12 is 48. 2 times 12 is 24, plus 42 is 66. And 5 times 12 is 60, plus 6 is 66. All right, so based on these angle measures, what two sides are congruent? Well, 66 and 66 are the same measure, so that means the sides opposite them are congruent. So this one and this one are congruent. So since angle U is congruent to angle G, that means that HU is congruent to HG. So that is the base angles theorem. Base angles of an isosceles triangle are congruent, and if two sides of a triangle or two angles of a triangle are congruent, the sides opposite them are also congruent. Very important theorem, and very useful too.